Hi lads, so we're back and I asked you to learn the symbols, something like 29 symbols, something like 25 elements involved, 25 elements, 29 symbols, because some elements come together and they make these radicals. And the radicals are hydroxide and nitrate and sulfate and carbonate. And the positive one is ammonium ions. So, learn the ions in the previous slide, parrot fashion, really important. Right? You guys are good at language, vocabulary. Do that kind of skill here. Learn these things parrot fashion. It's not about understanding, it's about just learning that sheet, learning the ions, and then today I'm going to tell you how to put them together to write the names correctly. So, as you've learned them, be very clear about capitals and lowercase. Be very clear that the charge is in the top right hand corner, like 2 positive. That's what I mean by number and flavour. Number is how many, flavour is whether it's positive and negative. Be very clear that if there are any small numbers, they're subscripted and they help you decide how many atoms of each you've got. The metals on your list will be the positively charged ones. The non-metals on your list will be the negatively charged ones. And when you've got 2 or more elements coming together, then we call it a radical, and learn those. So, what is the method? The method is not rocket science. The method is simply saying that if we had, say this pen was positively charged, say this pen top was negatively charged, let's say that pen top was 1 positive. Sorry, let's say the pen was 1 positive and the pen top is 1 negative. Then that 1 negative and 1 positive, if they were to come together, they would cancel out. The 1 positive would cancel out the 1 negative. As a consequence, that whole thing would not be charged. Well, let me tell you that every chemical in our world is not charged. Chemicals are neutral. Now, we do have charges in our world. I'm pretty sure that if I look at my cup of tea and I was to look inside that cup of tea, I would find ions, charged ions. But what I'm also sure about is if there were 100 trillion negatives in that cup, 100 trillion negatives would be balanced by 100 trillion positives. That the positives will exactly balance the negatives in any chemical that you have anywhere in chemistry, in your home, in laboratories, up and down the world, wherever you care to go. So that's the basic principle that I use to put the ions together, because I know that the ratio of positives to negatives has to be so that the overall chemical is neutral. So, from the name that we give you, you should be able to pick which ions make it up. So hydrogen oxide, hydrogen and oxygen. Sodium sulfate, sodium and sulfate is a radical, sulfate, sodium and sulfate. So from the name, it's easy, work out which ions. Having got the ions, then there's a bit of thinking. Put your thinking cap on. Bit of thinking. How many positives to how many negatives, bearing in mind the number of positive charges and the number of negative charges, bear all that in mind. How many do you need in order for the ratio? What ratio do you need so that when they come together, we're going to end up with something that's neutral. We're going to end up with something that's not charged. That's what that's trying to say. Once we know that the ratio 1 to 2, or ratio is 1 to 1, or 2 to 3, once we know the ratio, then we use small subscripted numbers to write down that ratio in order to write down the correct formula. And you guys need practice. I keep saying this. You need practice. You need practice. You need lots of practice. That final point. It's a bit blurred. Perhaps I should leave it a bit blurred, because it's simply saying, if you struggle with this, then sadly you will forever struggle with chemistry as a subject. So my response to that is, don't struggle with it. Practice and practice and practice. Practice makes perfect. Get it right. No more struggle. Understand what we're going to say in the future, because you know this, and then it helps you with your marks, and you become good at chemistry, and your life becomes rosy, and you end up somewhere wonderful, and all is good. Right, so if you were on your own, I would ask you to pick a positive ion, pick a positive, pick a negative ion, and then see if you write the formula for if they were to come together. And I can do this now with you. I'm going to have to put on my overhead projector, I'm afraid, because I haven't yet worked out how I can write in my computer and display it. So the first chemical I had was potassium iodide. So you can't see that, so it needs to be a bit lower. There we go. So potassium iodide. From the name, clearly potassium, you've learnt K plus. Iodide, I minus. So these are the ions from the name, the ions. Now, when they come together, how many of those will come into the box, which will be the formula? How many will come into the box in order to get the box being neutral, not charged? Well, I put it to you that for every one of those, you need one of those. Times 1. Times 1. One of those to one of those, 1 to 1. 1 to 1. How do you write that? Potassium 1, iodide 1. Ki. Do you understand that formula? Ki? It means 1K for 1 I. Ki. 1 to 1. The positive and the negative balance out. Can you see how my final answer did not have any charge written in the formula box? The formula box is the answer. The rest of it is just you thinking. Let's do the next example. Zinc oxide in the same way. Zinc oxide. Here, the zinc oxide, zinc and oxide ions, zinc and oxygen ions are both doubly charged. Doubly positive is the zinc, doubly negative is the oxygen. So, when that and that come together, you need one of those for one of those. Again, it's a 1 to 1 ratio. So it would be ZNO, zinc oxide. The ratio of zinc to oxygen 1:1, zinc oxide as a chemical, would be neutral if the numbers of zinc and oxygen were exactly balanced. That's why it's ZNO. Let's do the third example. Third example, sodium, I got the F this time. Sodium sulfide. In all of these examples, it's always ions coming together, making the correct formula. It's always like that. So, what chemicals do we need for sodium sulfide? Well, sodium is Na+, sulfide is S2-. Now, bit of thinking. How many of those to how many of those? Well, for every one of those, I need 2 sodiums. Can you see? Each one of those is two negative. To balance the 2 negative, I need 2 lots of single positive. 1 lot of that, 2-, would be 2 lots of that, 2 positive. That would balance that if it was 2:1. How do you show a ratio of 2:1? Na with a 2s. Na2s there. Na2s. You've got to have that ratio. You've got to have double the number of sodiums. For every 1 sulfur, you've got to have 2 sodiums. And the formula shows that elegantly. It shows it eloquently. It's Na2S. The S is 1, but you don't need the 1. Na2S1 or Na2S, sodium sulfide. It's just logical. The more you do, the more obvious it will become. I'm hoping it's starting to sound logical and obvious now. But a few more examples, and then you just pick any positive with any negative. Next one on the list, aluminium oxide. Now, aluminium is 3 positive. Oxygen is 2 negative. 3 positive, 2 negative. How about if we took 3 of those and 2 of those? 3 of those oxygens would give me a charge of 6 negative. 2 aluminiums would give me a charge of 6 positive. The 6 positive would balance the 6 negatives. How do we write it down? Al2O3. That's the formula of aluminium oxide. Next example. Can you see that? Iron 3 with chloride. I hope you can see that it's obvious. To get an overall neutral box, you're going to take, for every 1 iron, you're going to need 3 chlorines to balance it up in terms of charge. The square box then has the ratios but no charge. The charge is only in the circles. The charge is only there for you to think about. Fe, capital F small e, capital C small l, FeCl3, iron 3 chloride. How about iron 2 chloride? What if it was iron 2 with a chloride? Would the formula change? Well, yes it would, because if you took one of those iron 2s, you'd only need 2 chlorides. So it would be FeCl2. Can you see iron 3 plus, iron 2 plus? That's iron 3, this is iron 2. This is called iron 3 chloride. This is called iron 2 chloride. So the name is different. When we write it down, we show the 2 or the 3 as Roman numerals in a bracket. Now, do you need to do all this every time? No, it's just my way of getting you to think in the right, sensible, logical, simple way. However, what I expect you to do if you know the ions is simply know what the ions are and then to write the formula. So the last example I'm going to do, how about magnesium bromide? Well, magnesium would be Mg2 plus, bromide would be Br minus, and the formula would be MgBr2. And you just write it down. You would not need to do the 2 balls and the box of them coming together. When you've had some practice at this, you will just be able to write down the formula MgBr2. You will not need to write the ions separately and then bring them together. Hopefully, from the name, you'll know the ions in your head. You'll do the ratio thing in your head. You'll work out in your head how many of each you need, and you just write down the formula. And that's what we're aspiring to get up to. We're aspiring for you to be able to get up to writing formula, having learned that sheet. The sheet has to be learnt, previous lesson. But having learnt it, now, as you practice, I'm hoping simple thinking will give you the right formula every time. Haven't quite finished because we haven't dealt with any radicals, and it's radicals and brackets that make this whole topic exercise tricky. As my grandson says, anything he can't really do, he says, "Grandad, that's tricky." Or, well, he doesn't say Grandad because being Pakistani, he said Dada, Dada, that's tricky. Dada is Punjabi for Grandad. Right, so what if you had these things? Sodium hydroxide, ammonium chloride, magnesium nitrate, ammonium oxide, ammonium nitrate, ammonium sulfate. Oh, there's lots of ammoniums there. Aluminium carbonate, iron 2 hydroxide. Well, let's do those. Firstly, sodium hydroxide. I'm going to do them like this just to give you a different format. I'm going to do them as formula and ions. So, the first one, sodium hydroxide. The ions are sodium and hydroxide. Just think, how many of those? 1 to 1. How do we write it down? NaOH. See, ions formula. I hope I don't need to explain that. I hope that is obvious. Next one, ammonium chloride. Ammonium is that, chloride is that. Now, this is, ammonium is the first of our radicals. That's a radical. It's a radical because nitrogen capital N, hydrogen, capital H, nitrogen and hydrogen in the ratio of 1 to 4, 4 hydrogens for every 1 nitrogen. Those 5 atoms together can have, all of them can have a charge of 1 positive together as a group, as a radical. So then together, that 1 positive, how many chlorides do you need? Well, 1 to 1, one of those to one of those. How do you write it down? You just write ammonium NH4Cl. Formula NH4Cl. How about magnesium nitrate? Now, this is going to be slightly different. Magnesium and nitrate. Now, magnesium, 2 positively charged, you've learnt that. And nitrate, 1 negatively charged, you've learnt that from that sheet. Nitrate is a radical. It's made of 1 nitrogen and 3 oxygens. Those 4 atoms, 1 nitrogen, 3 oxygens, all together have a charge of 1 negative. How many of those? How many of those? The difference is you want 2 of these for every 1 of those. 1 to 2. 1 to 2. How do you write that down? Mg, 1. That's 1 magnesium nitrate. NO3. I said I want 2 of those. 2 lots of that. Oh, therein lies the problem. That now starts looking like MgNO32. And if I leave it like that, it's going to mean I've got 1 magnesium, 1 nitrogen and 32 oxygens. And that is not what I'm trying to show. I want 2 lots of nitrate. So you have to use brackets. On occasions, brackets must be used, and this is one of those occasions. I'm going to put the brackets in. Let's just get a different colour pen. What about putting the brackets in there? I want to put the nitrate inside the bracket. So the nitrate is inside the bracket. So that now it reads MgNO3 twice. And that's correct. I messed it up a bit, it's not very elegant, but that's correct. Mg, open brackets, NO3, close brackets, 2. 2 lots of nitrate with 1 magnesium ion. 1 magnesium is 2 positive, those single negative, 2 of them give you that is neutral. Ammonium oxide. Now, ammonium oxide. How many of those to how many of those? NH4 twice. Ammonium is 1 positive, oxygen is 2 negative, so you want 2 of those. NH4 in brackets, 2 of those. Can you see a pattern? I hope you can. Because plural, plural, group, group, plural, singular, singular group, singular group. Singular groups, singular radicals, when we call them radicals. Singularly, when they're on their own, you don't need a bracket. When you've got more than one, like plural, plural radicals is where you need a bracket. 2, 3, 4, 5, whatever. Plural, you must use a bracket. Because they've got their own little numbers. We don't want them to get confused with the quantity of radical that we want to show. So plural radicals must use brackets. If it's not plural, you never need brackets. If you haven't got radicals, you never need brackets. Even if you've got radicals, you never need brackets if it's singular. Plural radicals need brackets. Let me re-emphasize that with the examples. OH is a radical. Oh, you can't see that. OH is a radical but singular, therefore no need for brackets. Ammonium is a radical, but here singular, you don't need brackets. Nitrate is a radical, you want two of them, and therefore you must have brackets. Ammonium is a radical, it's a positive radical, but it's a radical nevertheless. We want two of them, and therefore you must have brackets. Brackets. So you need to understand where to put brackets in and where not to put brackets in. Let me quickly do the other examples that are left. Ammonium nitrate. NH4 plus is ammonium, nitrate is NO3 minus. The reason I picked this is to give you an example of having two radicals in one chemical. So, one of each, and singular, you don't need brackets. NH4, NO3, one of those to one of those, one to one, no need for any brackets. How about ammonium sulfate? Ammonium sulfate, I would say you need two of those. If you want two of them, you've got to have brackets. Why haven't we got bracket around the sulfate? Just one of those. One of those to two of those. Can you see the charges? One of those, so one sulfate to two ammoniums. Two ammoniums, plural, brackets. One sulfate, that's singular, no brackets. Aluminium carbonate. Aluminium carbonate is CO3, 2 minus. So, how many of those to how many of those? How about start with aluminium, two of those? Two of those would give us 6 positive. How many of these? We need 3 of them. Therefore, open brackets. CO3 is carbonate. 3 of them. That's the radical carbonate. And to take 3 of them, put it in a bracket, and 3 on the outside. And finally, iron 2 hydroxide. There. I hope that it makes sense what I've done. Turn this off. So now you need practice, and we've got sheets like this. Don't know if you can see that. Again, it's when I copy a worksheet onto PowerPoint, it kind of loses its definition. Do you need a worksheet? No. What you need are all the ions, the 29 or so ions, 25 elements with about 5 radicals. You need that list. And you have to be able to get any positive with any negative and put them together with the correct formula. You don't need a sheet. When I make up a sheet, that's what I'm doing. I'm just saying, right, I'll pick that positive, I'll pick that negative, and asking you the question. Well, you can make up your own examples and do your own by putting them together in that way. Finally, what points do I want you to know about? Well, I want you to know about the following points. I want you to know that capitals need to look like capitals. Lowercase letters need to look like lowercase letters. Formulae never, see that word never? Formulae never contain any positive and negative as they balance out overall. The positives and negatives are there for you to think about. They're the logic on which my exercise here hinges. It's got some logic, you think about it, you don't write them down. It's the ratio of positive to negative ions overall is shown by subscripted numbers. They're the numbers that you write down a bit. Brackets are needed with plural radicals. Otherwise, you never ever need brackets. Perhaps the most important point of all at the end. Practice makes perfect. Practice makes perfect, so practice. Right? I'll see you next time.